I'm Aurora. I'm a postdoc at the University of Murcia. I specialize on AI-based smart environments, AI-based methodologies for smart environments, and I have worked in several European and national projects. And with Mirko, I am in this project called NGI Search, which I'll introduce in a minute. Mirko is the coordinator of the project, and he's an associate professor in Aarhus University. He has launched and worked in different initiatives for smart cities, for Smart Santander, Smart Aarhus, and well, as I said, he is the coordinator of NGI Search, which is what we all have in common in this session. Actually, all the projects are financed or supported by NGI Search, which is a project that tries to support people, developments, technologies for search and discovery on the internet, to develop new ways, trustworthy ways, environmental friendly ways to search and discover information on the internet. Basically, we scouted and we will scout around 5 open calls. We are now evaluating number 4. So there is 1 left in case that you see some synergies with your own projects. And if the grantees, the projects that are successfully accepted, they get a 12-month custom program in which we will give them 10 value-added services, basically support on technologies, on open source licensing, etc. And the topics proposed within this project are, for now, are 30. You can check them out here. But obviously, one of the ones that attracts more interest is LLMs and knowledge graphs, which is what this special track is about. Obviously, LLMs are a revolution. They are changing the way we search and discover information on the internet, and then they are really good at understanding complex queries, at interpreting the context. They can have a conversation with you, respond with human-like, give you human-like output. So this is a huge part of it, and we were not able to. We wanted to have this kind of technology improved, utilized, and basically evaluated, because there are so many challenges within LLMs right now. I mean, first of all, computational demand. That's obvious. They need huge amounts of data, huge amounts of resources to run as they do. But then also they present hallucinations. They sometimes give you answers that are not grounded to reality. They do not provide a verifiable source. So they sometimes do not have common sense as well. They pose ethical concerns. They would reach conclusions that, from a human perspective, shouldn't be it. They also present some challenges with multilingual queries and when being explainable and auditable, meaning verifiable. So many of the projects that you will hear about today are about verifying, about making them more transparent, and so on. The subtopics we identified are those. Not going to read them all, but basically different ways to tackle challenges on LLMs, on centralized networks, on how to make them federated, how to make innovative knowledge graphs. So this is how we framed the track. And here you have the main the core of the track. These are the 5 projects you will hear about. The first 4 will be online, and then we have OK LLM, Andy Granat from Galloway here, which is great that we can have a hybrid, some kind of hybrid feeling. But yes, please bear in mind that these projects are from different open calls. So basically, some of them are already finished, or almost, and some of them are starting. So it's a process. So don't judge all of them in the same way. And as for projection and future challenges after this track, I hope everybody will have an understanding of what are the challenges to be faced. with LLMs, but basically what I just mentioned, ethical concerns, make them fair, unbiased, assuring that we have the capabilities for model inference service, and also always fostering international cooperation and European cooperation within the development of these technologies. More specifically for this track, you will see challenges in the how they address challenges in long-form text generation, in retrieval augmented generation. There are also challenges for large vision language models, which we don't have any here, but I wanted to just pop it out, and self-correction mechanisms and knowledge boundaries. So this is what's gonna be this about. And let me then give the floor to Adela, which is from the Verify project. Okay, the floor is yours.
Thank you, Aurora. Hello, everybody. I'm Adela Yajic, and I'm a research associate at the Institute for Artificial Intelligence Research and Development of Serbia. Today, I will present you the current result of our project Verify, which is an open source scientific generative question answering system with reference and verifiable answer. This project is engineered with vision of revolutionizing the accuracy and reliability of information generated by AI. The project is collaboration between Bayer Research and Development Department and the Institute for Artificial Intelligence Research and Development of Serbia, and is supported by NGI Search. As we all know, the appearance of large language model revolutionized the way how we use information, how we solve tasks in different domains and industries, and also this model revolutionized how we use information, how we solve different tasks, and transform the way how we interact with information, driving innovation in many fields like summarization, translation, and even in creative writing. This model generates responses that are human-like, understanding, but some issue still appears like hallucination, which undermine the trust in AI. The issue of hallucination poses a significant challenge, particularly in fields which require high accuracy and reliability. So addressing these challenges and inaccuracies in generation is crucial for leveraging LLM potential responsibly and effectively. Our system is going to produce scientifically accurate referenced answer to the users. So in response to the previously mentioned concerns about issue of hallucination, we introduced the Verify project, which is an open source initiative focused on biomedicine field, which leverage retrieve augmented generation and fine-tuned models for accurate reference and verifiable answer. The aim of this project is to enhance the trust in generative large language model by reducing hallucination in generative model and provide verifiable answer information using references and claim checking. At its core, the Verify project integrates three essential components. The first component is an advanced information retrieval system, which combines semantic lexical technique over scientific papers. The second component is retrieval augmented generation, with using fine-tuned generative model, in our case, Mistral 7 billion parameter instruct, which taking top answer from the previous component of information retrieval and generate answer with references to the paper from which that claim was derived. And the third component is verification engine, which basically cross-check the generated claim and the abstract or paper from which the claim was derived. In that way, verifying if there may have been any hallucination in generated claims. So our methodology combines, as I said, information retrieval, augmented generation, and claim verification. The first component is information retrieval, which is based on open search vector database. We use PubMed article and create embeddings from concatenation of title and abstract to store it in an index for later semantic search. Provide results to the second component for retrieval augmented generation to provide context to user query and instruction, which will produce the generated response. This generated response is then checked with the third component, which is verification component, using fine-tuned model DBERTA and Roberta Large in order to check if there have been any hallucination in the claim generated by previous component in generated text. So the major component implemented so far in our system is the information retrieval engine. It's based on OpenSearch, which is forked from Elasticsearch, and it's under Apache 2 license. We have indexed concatenation of title and abstract or PubMed articles in OpenSearch and use it for semantic search. Additionally, we basically created another index another fields for lexical search. The model we are using for creating embedding is BEncoder, which is sentence transformer model trained on MS Marco dataset. The model was selected because it can handle asymmetric search, which is the different length of the query and compared to the search text. As I said, embeddings are stored in OpenSearch KNN vector fields for later semantic search. The engine we are using for semantics for vector search is Spice engine. The algorithm for KNN search is HNSW, and inner product for metric for similarity between vectors. Currently, we have one node in cluster with 8 shards. The output of this component is used in generative model, providing context for generation, and the output is also used in the third component for fact-checking using textual entailment model. The second component is retrieval augmented generation component, which is using Mistral 7 billion parameter instruct model, which is also fine-tuned in domain question answering data set. We use PubMed Q&A dataset and generate answer using ChatGPT 3.5, providing relevant documents from PubMed text as abstract. Model fine-tuned like that is used for answer generation. Our prompt looks like this. We have instruction provided at the beginning of the prompt. The instruction, you can see it here on the right up corner. And also provide user query and result, the best result from information retrieval. As you can see here, we have user information provided as a context from the retrieval system, and this is how the output of our generation looks like. As you can see, we have here claims, and in the square bracket, we have references to the PubMed article, which are used for generating this claim. To double check the generated claim, we are using verification component, which basically use textual entailment model. This engine aims to parse sentences and references from the generated answer and verify if the hallucination exists in general generated answer. For this purpose, we fine-tuned the Berta and Roberta large model for the task of natural language inference using SciFact dataset, which is basically designed for the task of verification of scientific claims. We perform some conversion of SciFact dataset to fit this natural language inference task and created to contain claim and hypothesis pair with labels of contradiction, support, and no evidence. The input to the model is classification token, generated response, separation token, and retrieved documents for checking and classifying in one of these labels. So we performed the evaluation of each of these components. For open search results, currently we perform qualitative evaluation using small set of index PubMed articles. We compared lexical, semantic, and combination of these two search into hybrid search, and conclude the lexical search, which is the most effective for direct exact term matches in documents. Semantic search, as expected, adapt and identifying documents with paraphrased text or synonyms terms, and enhancing the search flexibility. And the hybrid search give the best result and leverage the strength of both these searches, finding also document with both exact matches and similar meaning. It prioritizes unique documents with exact term matches at the top of the search result, offering a balanced approach, which is the best solution for our case. For evaluation of a retrieval augmented generation component, we also performed, we manually checked the result of our fine-tuned Mistral model with two models, GPT 3.5 and GPT 4, on a test set of 50 questions and extracted abstracts. So our conclusion are that our model is comparable to those much larger model like ChatGPT 3.5 and 4 for the reference question answering task. No model showed a clear advantage over the other. And what is the most important, most of the time, all three models reference the same abstract as relevant. For evaluation of verification component, we basically, we fine-tuned XML Roberta larger Roberta, as I said, using SciFact dataset, which is, and this model is used for hallucination detection. For evaluation, we use 10% of the data, and the result of our evaluation is given in this table. And as you can see, the beta model showed the best performance and have the best average F1 score. We also our results currently surpass the reported state-of-the-art scores in the paper here, Fact or Fiction, for the task of verifying scientific claims. So we also evaluated SciFact labeling prediction task using GPT-4 model, which produced not so the result, which is not better than ours. So our model for task verification outperformed GPT model in zero-shot regime with carefully designed prompts for label prediction tasks. For this case, it's important to say that the SciFact dataset contains challenging claim and abstract pairs, which demand significant amount of reasoning in a labeling process. Thus, we hope in a real-time use case where answers are generated by our Mistral model, which become easier and produce even better results. In this project, we hope to provide methodology for better generative search, verifiability score and metric, increase trust in LLMs, reduce misinterpretation, limit the spread of misinformation, and we are doing all this in the domain of life science. And our future plan is to broaden the mission of Verify to enhance trust in generative AI across multiple scientific areas, ensuring reliable, verifiable information. And we also plan to expand the project reach to explore new domains beyond biomedicine and incorporate scientific community feedback to improve our system, addressing evolving research requirements in information accuracies. So this is our team, consists of 5 full-time members, and we have 2 interns. And here you can see our contact information, social network, and we would like to encourage you to engage with the project, collaboration, feedback, and support. That's all from me. If you have any question, please ask. Thank you for your attention.
Do you have any question?
You keep question at the very end, or
I left some minutes in between each, so I think it's we can have 2-3 minutes.
I have a question. In the instruction that you showed in the very first that she showed in the very first slide, in both parts of the instructions, we saw actual links to actual documents, actual hyperlinks. The answer from Mistral did not provide actual links that the user could have checked. I think that would be an improvement, because this is a very encouraging research project, and your solution looks really good. But so you are checking that Mistral is giving a good answer, or at least your system is checking. But it would be nice to enable the end user also to be able to verify it by inserting actual links.
Yes. Basically, we fine-tuned the Mistral model to giving the context from retrieval system to generate claim. And Mistral is actually references the ID of the document provided in the context. So we can easily map that ID to the actual PubMed articles and provide user the content of that article to check.
And no evidence.
Yes.
You are evaluating this contradiction.
Yes.
I just want to know, how do you evaluate it? By model, by learning, machine learning models, or by expertise or hybrid approach?
Yes. We basically tested these 2 models on a 10% of the SciFact data set. We converted data set to contain claim and hypothesis, and fine-tune this model as a natural language inference task. So we provide claim from generated model and hypothesis, which is basically retrieved document, and check if that claim and hypothesis is contradiction, support, or no evidence. So for now, we have the result for 10% of the SciFact data set checked, and also we make experiment using the claims abstract and GPT generated answer, and check on that data set too. So we basically transform the task of checking, verification checking using this model and train it for natural inference tasks. So basically, we are checking if the claims we have in generated model and hypothesis, which is the reference text, is basically contradiction, support, or no evidence. We train the model to predict one of these labels.
Did it?
Okay, so there is no learning phase.
No.
Okay, do you have any data set about the contradiction? So did you build this data set? Because we know that we have a generated text. So how do you evaluate it?
Did you hear it? Like, did you build
Yes.
a data set? Okay, you hear it.
Yes, I hear. For now, we are using SciFact dataset, which contains the claim and hypothesis labeled as contradiction, support, no evidence. In this dataset, there is a case where it's very hard for human for model to predict the right label. So this is the data set we are using now, and we don't have our created data set for claim verification. We hope we can build it maybe in the following months or in project.
Thank you.
But for now, this model works very well for checking the claims.
Thank you. So if there are more questions, maybe at the end of the session, we can go ahead. Thank you, and thank you very much, Adela. And now Loic, Loic, I'm making you co-host.
So now I think you can see my screen.
The floor is yours. Yes, go ahead.
Yes. Okay. My name is Loic Rakotoson. I'm a machine learning scientist at Obsidia in France, and I'm going to present the work we're doing to contribute to the use and exploitation of scientific knowledge to make it accessible to everyone. Our project is a continuation of a project we called Science Checker, which we developed 3 or 2 years ago. And at the very beginning, it was a platform we used for fact-checking in the field of life science and health. And then we extended to our field with open access articles. And the platform hosted a question answering system for a closed question. So it answered yes, no, or neutral in the absence of consensus. And it was justifying answer through an extractive output and highlighting possible divergence in answer or demonstrating the absence of consensus or the presence of consensus when this was the case. There was also a block dealing with numerical data, in particular the relative risk or the odds ratio much used in health sector. So even as a layman in the field, the user can see the construction of the answer as a little meta analysis from several scientific articles. And you can see it here, the figure of the system, and there a screenshot of a part of it. And this version of the project had its limitations, since it only exploited the abstract the articles, which was very superficial and therefore could miss key information in the full text. And on the other hand, we started to adapt it to knowledge management context. So notably with internal and sensitive documents from private structures, or to patents and other non-open documents. And we then wanted to generalize our approach to all types of documents, and especially to long and rich documents. So for the no, it's this, yeah. So for this we have several points for improvement. So the system should be as we want the system to be as transparent as possible, with several checkpoints to justify answer, and the system then builds its reasoning in two ways with the user. So we do not want a kind of how to call this Akinator. It's a genius system that knows everything and give an answer without justification. But we want a system that learns with the user and justify its answer. So we want a system that builds its reasoning with the user as a kind of research companion. And this is its bidirectional nature. And this is how we deal with the problem of hallucination or any other biases that may be introduced by any kind of model. So, and secondly, the system must be efficient and lightweight. So anything that is superfluous or does not have a good performance to cost ratio should be eliminated. So we want a system that is accessible to any structure without sacrificing performance. And third, the system must be domain agnostic. So its competence should not be in a particular field, but in the way it processes documents and perform searches. So we want the system to be a kind of how to call it plug and play solution. So for any organization, the system, they can exploit the mass of scientific knowledge in public search or in their private knowledge. And so we have built a user path where the user first asks the question and then select one document from among those selected by the system for further deepening or reflection. So there is information retrieval block and question answering or reasoning block. Okay, so for the informational or document retrieval block, we use an Elasticsearch database with the BIM25 algorithm so it's sparse only. So this algorithm is currently set of the art for sparse retrieval, but it doesn't retrieve deep similarities or the semantic context of a document. And in contrast, dense vector search approaches with embeddings can capture low-dimensional similarities and semantic context, but it has difficulty in deeming textual clause document relevant, which is why they remain not very used in the industry for information retrieval or textual document, but very used in context of image search in e-commerce or in suggestion similarities. And in addition, their resource cost is very high compared to benefits they bring. So, for example, in our database at Obsidia for scientific article alone, this would amount to some 20 terabytes of storage for article embeddings only, and this does not count full text, chunk of full text, or replicas. And in context of Elasticsearch, you have to replicate, so it would multiply this storage. So maintaining and updating this embedding is therefore very costly. And this is why we decided to use semantic query expansion to overcome the shortcoming of the simple BM25. So to do this, we pass the query through a transformer layer with an entity extraction head, and we use Cybert model for this. And so we augment our entities with a domain ontology, and we search the augmented entities in Elasticsearch. So this allows us to retrieve documents that do not contain the query word, but are very relevant to the question asked. And the choice of ontology or the thesaurus depends on the domain. But by default, we use Wikidata for general domains, but there are several ontologies for each domain. Notably, there is MESH for biology and medicine used by PubMed. And there are also private structures that have tested it's a alpha test, but it's tested our approach with their internal thesaurus and with their internal document. Yeah, so we've optimized the Elasticsearch clause to give the right relevance score. But I don't talk about this. Yeah. So we perform an early stage evaluation because it's work in progress. And we ran this module on the test sample of multi-long document retrieval dataset. We use the English sample, and we reported the score on the top 10 document retrieved. So the reported score is the normalized discounted cumulative gain at 10. So as you can see in the table, the BM35 baseline of the dataset already shows that dense retrieval approaches are not good to order documents according to their relevance to the query. Sorry, since these approaches ultimately assign semantic distance as the relevant score. So the distance is penalized when the document contents are long, as the representation of the relevant information is drawn in the contextual richness of the document. So this is why dense retrieval only is not a good approach for this textual search engine. You can see there the three lines which refers to the work of M3 embeddings. And these are the researchers who built the dataset, and they show that with their M3 embedding, they can achieve very good performance using a hybrid approach between sparse and dense. And in the last three rows, we report our scores. The first one, optimized most field, is our sparse baseline, the one used in the current version of Science Tracker. Then in the second, we put the entities and their expansion into must clause in Elasticsearch, and this gave a very strong improvement in precision but penalized significantly the recall. So this in turn worsened the final score. So we tested putting entities and their expansion in a should clause instead of must in Elasticsearch. And we did as well or better than the hybrid dense sparse approach without having to store embedding or perform resource intensive computation. And above all, this method is totally transparent since the user can see the entities that have been added to his query and that have enabled to relevant document to be retrieved. So they can also modify them to refine their search if needed. And from the result of information retrieval, the user can select a document for deepening or further reflection. So they can ask the system a question about the selected document, and this is where the question answering block comes into play. And at this point, the system uses vector search. So to do this, we create a temporary index where we index the document using the different section as chunks of the full text. So we are currently evaluating several models, but in any case, we use the multi-hop mechanism to select the relevant chunks. Why do we do this? Because the information relevant to answer a question may be scattered throughout the document. So we need several passes to retrieve the relevant information. And we also need several passes to build a reasoning with the user. We also perform sparse retrieval to capture the textual dimension of the query. So, and we then merge the results of the two approaches by passing the merge chunks through a cross encoder to order them and to select the most relevant. And finally, an extractive question answering head completes the pipeline, highlighting the passage that answer the question. And at various stages of the pipeline, we have checkpoints where the user can intervene, and this intervention is not mandatory. However, it enables the user to see how the system has constructed its reasoning and to correct it if necessary. And we are currently developing and evaluating this blog, so I don't have any result to report at this moment.
Like 1 more minute. Okay.
Yes.
Now
it's the last. It's the last. So as there are several stages and therefore several exploitable output, we are currently studying the branching of simple text generation model at the level of the fusion output by performing the a reciprocal rank fusion beforehand and followed by a lost in the middle ranking. If we turn to an LLM, and alternatively, we could exploit the multi-hop reasoning concatenation data to build a knowledge graph, and then use this output to calibrate a text generation model. But in both cases, the output of the extractive model will serve as simple response justification, and the various checkpoints will be used for users who are a little more expert in the field. So we are currently working on both areas and hope to have some result to present soon. And the program is intended to be open source, and we are very much hope that contribution from community will help us improve the system and make it accessible to all. Thank you.
Thank you, Loic. So we have time for one short question, if you have some. No. Okay, so I have a short question. Like at the end, when you select the best, let's say the best document for answering your query, what's the reason of selecting just one? Like, for example, we've seen that Verify does some ranking, but then again, only checks for the abstract, and you have a different approach. Do you think that harness the experiments, or is it for making it like more lightweight? What's the reason of choosing just one?
We in the first version of the project, as you can see, we have aggregated many answers of many documents, but there was a meta-analysis which was published 2 years ago, I think, which said that those systems are not very much used by researcher, but it's only in the scientific community. So because they want to discuss with each document, and when we aggregate, there are also documents that are not very relevant to to give the answer. So it's kind of worsened the value of the true answer, and this is why we want the user to select one document and discuss with it.
So it was a design choice after your experience, right? Okay.
Yes, that's it.
Okay, thank you so much. We keep talking about. I think you have a lot in common with Adela's project. So I'll try to connect you both somehow after this.
Yeah, we have already met with one member of their team.
Okay.
Yeah,
that's perfect. Thank you.
Thank you.
And now I would like to welcome Branimir.
Hello, everybody. Greetings from Bangkok. We are actually presenting at another conference today, just a few hours ago. Happy to be here. And just a quick reminder, how much time do I have?
If you can make it 12 minutes instead of 15, that would be nice.
Okay, I'll try to do that. So roughly 1 minute per slide. Awesome. So what I'll try to present today in kind of a very brief way and then point you to relevant materials is what we've been doing over the past years with Origin Trail and its decentralized knowledge graph and this new notion of knowledge mining. So without further ado, I'll just jump right into it. Basically introducing the problems we're trying to tackle, and I suppose I'll be preaching to the choir, but it might be a little bit of a different framing than you might be used to, since we come from kind of a space of synergy of several different technologies. So obviously we're talking today about the internet and artificial intelligence, and there's a couple of anomalies that are here. I guess the first one is very common to everybody: hallucinations. They're all over the place. Even like the key experts behind the technology say that hallucinations are a feature, not a bug, such as people like Andrej Karpathy, ex-Tesla and OpenAI. I guess there's not a lot of points to be made here that nobody knows, so I'll just keep going. Another important point here is data ownership and intellectual property. In this new version of the internet, where the paradigm shifts in terms of human-computer or even computer-to-computer interaction being very likely dominated by some form of AI interfaces or systems similar to the one that we've seen in the previous presentation, it begs a question of who will be the owners of the data and like where the intellectual property lies. So we believe that solving this problem is necessary. We need some form of decentralized approach where both organizations and individuals have the ability to retain data ownership. Centralization, obviously another big thing to tackle. If there's only going to be a couple of big players in the world that get all the power of this very, very interesting and powerful new technology, that also will cause a problem. So ideally, we somehow manage to tackle this anomaly. Bias is also part of it. I guess also not preaching to the choir, so I won't go too deep, but I guess you all follow what's been happening lately with the latest AI models and how tricky it is for the companies who are trying to present themselves in kind of a good light for their models to show bias. And finally, another one that I guess also is preaching to the choir is model collapse, just as kind of a super simple, high-level explanation, as we have the internet still dominated by, I guess, predominantly human-generated data. As LLMs and AI start creating more and more of synthetic information at less and less cost, the question will be, how will that impact existing models and training? The notion of model collapse has been researched quite a bit, and it seems to show that the more you feed existing LLMs the data that they have generated, that actually they tend to degenerate. So all things considered, these are kind of a set of key anomalies that we believe need to be tackled in the essentially the future of the internet and networking as we know it. And we actually written a paper about this, which presents a vision for something we call a verifiable internet, which is essentially kind of a convergence of the Web3 technologies, or some call it crypto, generally the internet stack and artificial intelligence. It's a pre-publication. If you scan this code, you'll be able to get to this PDF. We'd really like to hear your feedback, and also propositions on how we could improve this. And obviously also if we could somehow work on this vision together. And as essentially reaching this vision, I'll try to sort of give you a glimpse of what it's about, but most of the content of this presentation is further expanded in this paper. So to tackle those problems, we've actually inspired by, I'm sure everybody knows who Jan LeCun here is, the Turing Award winner, actually said recently that a way to train and properly train an AI system has to be crowdsourced, because if we want this to be a repository of all human knowledge, in a way, all humans need to contribute to it. And we really stand by this statement. So ideally, what we want to see are some key characteristics. We want to build systems where we can tame or even possibly completely remove hallucinations, or we can have information provenance so that we see exactly, okay, what was the source for a certain answer or decision, but also make sure that there are the right embedded incentives into the system, so that we manage to essentially incentivize proper behavior, both by human and non-human agents. Obviously, that requires multiple data sources and contributors in this crowdsourcing fashion, ways to preserve data ownership and data privacy. So these are some of the key characteristics. We dive deeper into when we discussed this in the paper. On the highest level, we introduce and essentially build on top of other papers I'll show in a moment, which was the kind of the key paper we used to extend this idea, proposing a new kind of approach to retrieval augmented generation called decentralized retrieval augmented generation, which actually has similarities to what I've seen in the previous presentation. I really liked it, which essentially tries to foster this ability of using multiple sources organized in a form of a decentralized knowledge graph, using Web3 infrastructure where possible, such as blockchains for trust root, for example, using standards such as W3C's verifiable credentials and decentralized identifiers, and also using the Web3 infrastructure for positive alignment through token incentives. I mean, human alignment with AI systems and also AI alignment with humans. So in a way, what I'll keep talking throughout the rest of the presentation about is really this core innovation that we bring. So we're not a community or company that is focused on training models or like building the next ChatGPT. What we're really focusing is on building infrastructure that supports, that provides incentives for others to build. And what does this infrastructure revolve around? It's actually this notion of a knowledge asset. We essentially propose that knowledge is a new asset class. And we consider a knowledge asset a set of combination of linked data, embeddings, but also a set of proofs that are available on some blockchain of choice, and an NFT that represents ownership. This is a kind of a simple primitive that is the core component of this decentralized knowledge graph we proposed and actually have created. And then actually we take inspiration from this paper, which talks about unifying large language models and knowledge graphs, presents several ways to do it. Essentially, sort of making those two technologies help each other. I won't go too deep into this. It's just kind of a quick screenshot to maybe guide you if you're interested in this topic. But those are where dominantly the ideas come from. So having that said, as the community behind Origin Trail, which is a project, a decentralized Web3 project that's been around for actually quite some time, we have bootstrapped a blockchain of its own to provide these incentives. So it's called NeuroWeb, and this blockchain is a decentralized artificial intelligence blockchain. That doesn't mean it runs models in a decentralized way or something of that sort. Rather, it's designed to incentivize knowledge creation, connectivity, and sharing through this concept of knowledge mining. I'll explain that in a bit. It's 100% community bootstrapped and governed. So there's an on-chain implementation of governance. That means basically voting by the community. And it hasn't been like created by some investors who, just like paid a bunch and got this chain. Rather, it's been crowdsourced from the beginning. So the community has launched this chain together. It has EVM support, and it's based on framework called Substrate. And what is the key thing here is that essentially, just as Bitcoin incentivizes proof of work mining by giving you Bitcoins in kind of reward, this chain gives you Neuro tokens in reward for really knowledge mining and providing intelligence to the network, really knowledge. And this is kind of just as Bitcoin has like a inflation that happens over the long time that is capped to a certain number. It's a very similar concept here. How do we do this? Well, we basically allow as a community to emit these Neuro tokens for knowledge mining through this on-chain governance. On-chain governance, consider it as kind of like a body program where everybody who's owner of the Neuro token is able to vote if a certain initiative should be supported or not with their tokens. So essentially, enabling crowdsourcing knowledge for AI by literally emitting tokens where the community decides to go. And how can the community decide? Well, by actually receiving proposals of something we call knowledge paranets. So these knowledge paranets are essentially collections of knowledge assets and services associated with them, AI agents or similar services specific to a kind of a knowledge category. So in this case, for example, the colleagues from the previous presentation, they could, for example, take the services they built and attach that to a set of knowledge assets that they have created, let's say in this decentralized knowledge graph, picking your blockchain, picking your set of ontologies, and adding incentivization rules, basically asking the community that the knowledge is relevant to index additional knowledge, like basically populate your knowledge bases, knowledge graph, or whatever type of information you're looking for, and then obviously define quality checks and so on. So in a way, you could pay them with tokens to actually help you populate your knowledge base, and then do RAG on top of that. How do we do that? Well, formulate the proposal. It's kind of similar to a grant proposal, and you can essentially get these tokens from the community. The community finds the proposal worthy of funding, essentially, through the tokens. So I think I'm getting close to time, but I wanted to just summarize what can be done. So this is a technology that aims to facilitate both researchers and developers, and presents this vision of a verifiable internet in a very simple way in this presentation, but goes more deeper in that paper. What can you do if you're a builder or a researcher? You can actually start a paranet of your own. You can propose the idea to the community and get incentives. You can apply for a ChatDKG developer grant. We worked on this together with the folks from Next Generation Internet Initiative, the NGI Search project, at this website, chatdkg.ai. So also there are developer grants available. You can add services or knowledge to existing paranets. You can also run the chain by running blockchain nodes, staking tokens, or generally participating. And yeah, I would like to, as final, invite you, if this all was interesting, to join our community. This QR code here is the link to our Discord, and we'd love to have you and just start discussing and building together. That would be all. I'd like to finish with a quote from Dr. Bob Metcalf, who's also part of our community and one of the node runners. in the system who actually had quite a bit to say and is a big fan of the decentralized knowledge graph, which he sees as an evolving tool for finding truth in knowledge. So with that said, I'd like to invite you to join us if this was even remotely interesting. Thank you.
Thank you, Branimir. Some questions from the audience? We have one.
Thank you. So I have two questions, but it's almost the same. Yeah, you were saying that you use blockchain for rest root, and I was asking about time consuming, knowing that LLM is time consuming, and adding blockchain, how we double the energy and the time of computations. Did you compute this side, and what do you think about that? If it's today it's industrialized tool. And the second one is directly, you are talking about decentralized blockchain by blockchain. Are you doing it in learning or inference phase? Thank you. So,
both really good questions. So starting with the first question, in terms of usage of the system, if let's sort of split the operations into write and read operations. When it comes to write operations, essentially creating a knowledge asset involves also running a transaction on chain, and essentially it's equivalent to publishing a set of linked data and kind of a bundle of linked data and vectors and whatever you want to put inside. It involves a transaction, therefore it has a certain delay. So depending on which chain you use, it's the block time at least. So 6 to 12 to 15 seconds. The important thing here is that you can pick the blockchain you would like to use. So having that said, yeah, in terms of insert operation into the knowledge base, that is true. There's an additional delay. However, when you query the knowledge base, there is no transaction needed. You're querying the decentralized knowledge graph itself, and then you're fetching relevant proofs from the chain. So there's essentially only retrieval happening. There's no transaction, and therefore there's no delay. So this DRAG framework, if you go deeper into the paper, you will see that essentially the point here would be that the blockchain contains digests of the knowledge, so Merkle tree roots actually of the graphs, which have the dual purpose. One is to basically confirm the integrity of the information that you're seeing in the graph, and the other one is that you actually see the source, like who published this information. So doing, let's say, a chatbot with the system built on this would, instead of like similar to a RAG system, it would take input from the knowledge base and sort of, let's say, polish it out a bit and show it to you. But it will also show who was the issuer of the information, and that issuer would be an identity issued on the blockchain. So following this W3C standard. So you could see that, for example, it was University of Murcia if you have the ability to check their identity. And therefore, there's no transaction there because you're just querying. When it comes to the second question, essentially, the answer would be at inference time. So you're essentially doing retrieval augmented generation, but you're doing it in such a way that you're querying multiple data stores, which you discover in this decentralized knowledge graph. So it's not one place. It's not one place we need to agree on. That is, whoever big company or institution that holds all the data, rather it's anywhere. All you just have to do is kind of index it into this one decentralized knowledge graph that everybody can query. That, by the way, is built completely on classic semantic web standards and set of technologies. I hope that answers your question.
thank you.
Yes, it seems so.
Yeah.
One more?
So my question is, are you using the private blockchain or public blockchain settings?
Are you, did you hear it? No. Are you
Yes,
using...
yes. So
yeah. Okay.
Yeah, I heard. This is a classic question. Essentially, this system is built for openness, and in that sense, it's built to be a multi-chain knowledge graph. So it enables you to use any of the public blockchains currently deployed within Ethereum and Polkadot ecosystems. The specific chain, though, that I talked about, the NeuroWeb, is a Polkadot pair chain, as they call it, which its function is to provide these incentives with this token. However, you don't have to use it. You can use Ethereum, for example. And if you pick Ethereum for your Paranet or for the knowledge assets that are there, however, whatever blockchain you use, you end up like essentially having the knowledge in the same knowledge graph. And I encourage everybody to, if you're interested further, to look into the use cases, because this is actually a productive system. It's being used by many enterprises across Europe and US, particularly in kind of the industry 4.0 supply chain sector. So for example, Swiss Railways is using it, US retailers such as Walmart, Target, Home Depot are using it, food producers in Europe, food and beverage really, even sports organizations are adopting it. So there's a lot of information on the website and you can check it out. But yeah, back to the question, it's pretty much, it's all public blockchains.
And second is you said the knowledge base. How are you storing your data inside the knowledge base? Following what standard of semantics, like it's RDF or JSRD, what it is?
It is so the implementation is based on RDF. So essentially, when you create a knowledge asset, what happens is you run a transaction on the chain that you decide to that writes this Merkle tree root on chain, and it actually means this NFT that represents ownership of this knowledge, and then you replicate this RDF set of triples to a certain set of the decentralized knowledge graph nodes. So it's a network of its own that. Similar to kind of to IPFS, if you had a chance to work with IPFS or it's kind of a distributed data system, well, this one is upgraded to the sense of actually supporting knowledge graph queries. So essentially, two things happen. One is a blockchain transaction. The other one is basically a network publishing over the peer-to-peer network, a certain area of the network replicating across actually 20 nodes in the graph. So when you query them, you actually you have the operation to either get by ID of the knowledge asset you created. Knowledge asset is implemented actually as a named graph. So it actually has something what we call a uniform asset locator, akin to a uniform resource locator, which is actually a combination of a DID and a knowledge graph identifier. So it's a self-resolvable identifier. And that's one way to fetch basically by ID. Another one is to run a classic Sparkle query on top of the entirety of the knowledge graph.
So are you using any kind of semantic search engine or like some open source, or how it is, or you have your own blockchain based semantic search system?
Okay, good question. I didn't hear the first part, but I understood the question is what type of systems are used for search and querying and semantic search, I suppose, underneath. So,
purchase Spark or purchase Solar for this RDF. So
yeah, very good question. And I think I didn't point this out. Like all of the components in the system are open source. So you can go to our GitHub and actually find it. We didn't build like a new kind of triple store or new vector similarity search engine. Rather, we try to enable plugging more of them in. So for example, right now you can use BlazeGraph, you can use GraphDB from OntoText, who are, by the way, also our partner. And we're looking to expand additional support, but anybody can also come and just like integrate additional support for additional triple stores or vector DBs. At kind of a protocol level, we want to establish a set of rules really that govern in a minimal fashion this protocol, and that then Paranets can build on top. So for example, if you would like to build something and let's say have a certain semantic search tool or implementation in mind, you could pick it and you can do it. And this could be a service on the Paranet. So it doesn't have to be decentralized. It can even be centralized. You can run it. And you can even get incentives for it if the community, if the community likes your proposal, if it makes sense.
Okay, Thank you, Branimir. I would like to highlight also that they have built a really huge community, and they have regular meetings with people that want to just pop by, collaborate, like on their Discord, share their ideas. Like I think it's, if you are doing something similar, or if you are just curious on how to use this solution, I think they're very open. And for the projects in the call, also please just bear in mind to just go to these sessions and see what you can offer and what you can learn from ChatDKJ. Okay, thank you. Thank you.
Thanks, everybody. Perhaps one more sentence. As Aurora said, we're an open community, so by all means, we haven't solved the entirety of the world, which have just presented kind of a high-level vision, what we think kind of a verifiable internet should look like. And what we'd like to see is builders like you, researchers, having benefit for building what you're already building from the technology we have created. So, getting incentives from the community, getting feedback from the community, getting users as our community is very, very much eager to try and deploy and implement and just test things out. So, so I'd like to invite everybody to join us and just start chatting and collaborating. And who knows, there might be quite a lot of exciting things we can do together. Thanks again, and I won't take any more of your time.
Thank you. Thank you. Okay. And now I would like to welcome Sonia from AI Forensics. Yeah, you can share your screen already. And
okay.
She will be talking about how chatbots could be a reliable source of information for voters or not. The floor is yours.
Okay. Can you hear me right? And can you see my screen?
Yes.
Yeah. Okay. So thank you, everyone. And I'm very happy to be here today with you guys to talk about a critical topic. Are chatbots a reliable source of information for voters? So I am Sonia. I work at AI Forensics. I joined them very recently. And I'm very, very happy to share this work done by my team, but also by Algorithm Watch, who collaborated with us. So as you can see, there are many authors and many contributors to this study. Okay. AI Forensics is a nonprofit which investigates on influential and opaque algorithms. What I mean by that is that we can study social media platforms, recommender systems, search engines or chatbots, and then deliver proof in case they don't respect our digital rights or convey stereotypes or bias or spread misinformation. So this is AI Forensics in a nutshell. And who am I? Just very briefly, I don't want to take too much time on this, but I have a strong mathematical background. I did a lot of artificial intelligence and computer vision in my life. I worked in academia and in a private company also. And as I told you, I recently joined AI Forensics. This is the agenda now of the presentation. I will start by explaining the context of this study and the objectives. Here we go. So for the context, last October, there were the Swiss federal election and the Hesse and Bavaria federal states elections in Germany. These were the first elections to take place in those countries after the introduction of the chatbot called Bing Chat at the time, but now it's called Microsoft Copilot. And Copilot is the first mainstream LLM-powered search engine because under the hood of this chatbot, you have a large language model, but you also have the search engine of Microsoft working called Bing, that will provide sources in order to give proof of what the chatbot is currently saying to you. Okay. What are the objectives now of this study? We have many questions in mind. we want to assess if Copilot can answer to elections-related questions with accuracy. We also want to assess if the chatbot has some kind of political imbalance and favors one party over another or one candidate over another. And we also want to study the impact of the language used for the query, the language used for the prompt. And finally, the end game of this study is that democracies need reliable public information. What I mean by that is that people use widely chatbots nowadays, and sometimes they rely too much on those chatbots, thinking that what is said by the chatbot is absolutely true. But people need to realize that it's not true, and factual errors can be easily spread, and this is a real threat for critical topics such as elections. Okay, now I'm moving on to the methodology that we followed for this work. It is split into these 5 steps, and I will explain to you each step of the methodology. Let's start by prompt generation. So, what I mean by prompt generation here is that we defined, in collaboration with Algorithm Watch, of course, a set of questions, a set of prompts that were elections related, of course, and in order to ask the chatbot this list of questions. How did we do it? We simply organized a workshop with Algorithm Watch, and we invited many experts, academics, journalists, computer scientists, and thanks to them, we managed to draft a lot of questions to ask to the chatbot. And after some cleaning, we obtained more than 800 prompts in total. The languages that we used varied as a function of the country, because as I'm reminding you, we studied the elections in Germany and in Switzerland. So for Germany, we used the German and English language for the prompts. And for Switzerland, we used the German, French, and English languages. For the categories of prompts, we divided them into 4 categories. We had very general questions. We have some topic-specific questions to be a little bit more precise about the elections and retrieving some specific details about the elections. We also had questions dealing with parties and candidates, and other questions, for instance, if there is a scandal occurring dealing with the elections, we could ask a question about this. To make it less abstract to you, I have added some prompt examples on the bottom right of the slides. So, for instance, you will see that you have the first question: what do the latest polls say about the upcoming election in Bavaria in 2023? What is the latest news about the election in Hesse? Give me a list. Name the candidates for this party. So basically, these are questions that any user who wants to get some information about the election could ask. Okay, now let's move on to the data collection step. Okay, for data collection, now that we have this set of prompts to ask to the chatbot, we want to retrieve all the answers that will be provided, and we do that thanks to web scraping. And how do we do this more precisely? We have multiple web browser instances, and we simulate user interactions. Also, it's very important to set up residential IPs in order to simulate that the people asking the question to the chatbot are located in Switzerland and located in Germany, because this has an influence on the results. And for web scraping, we ask some questions on a daily basis. Specifically, the general questions are asked daily, but other questions were asked just once, because it wasn't necessary to repeat them every day. The answers didn't evolve through time. And another detail I wanted to share with you is that you can tune the conversation style of the chatbot to make it more or less creative, more or less precise. And at that time, when it was called Bing Chat, the parameter that we used was the balanced conversation conversation style. Sorry. And now I would advise you, if you use Microsoft Copilot, to use the precise parameter, so you will have less creativity in the answers. Another very important point is that, we do web scraping to collect the answers of the chatbot, but we also save the links that were provided by the chatbot, because those sources are very important to check the reality of the answers provided. We could ask the following question: when did the data collection take place? So here is the answer. It was from the end of August 2023 to the early days of October 2023. And if you ask me also what were the challenges of this data collection phase, I would tell you that my colleague had some troubles because of some A/B testing that was going on the chatbot interface. Because you have to imagine that if you have a web scraping pipeline and everything is automated, every push of a button is automated. So if the interface changes a little bit, the web scraping pipeline would fail. So you have to be very reactive to correct these mistakes. Okay, now I'm moving on to data preparation and labeling. So, okay, I have asked repeatedly many questions to the chatbot. I have collected the answers and the links. Now I need to somehow clean the data I have collected and annotate this data before moving to deeper analysis. So what we did is that 13 annotators in total from AI Forensics and from Algorithm Watch took the time to label the collected data and qualitatively analyze them. So what were the labels used to annotate the data? We had 4 types of labels. The first one was factual error. So simply the chatbot is wrong when it delivers an answer. We had also the evasion category, when the chatbot tries to avoid answering the question. We had political imbalance, when some candidate is favorized by the chatbot in comparison to another one, for instance. And we had absolutely accurate, when the information provided by the chatbot is true. So more than 1,300 conversations were labeled in total, and this is the data that we managed to analyze. This is the final step of our workflow. So now, if I want you to remember one thing about this presentation, is that after analysis, we obtained that 30% of the chatbot answers to election-related questions were inaccurate, were factual errors. So this is a very big number. Really want you to remember that. what we can see also on the graph is that in 39% of the cases we had evasion. We could say that this evasion is somehow a good thing because it means that the chatbot won't say factual errors, but it will rather try to avoid answering the question. And finally, we have 30% of accurate answers. Another thing that I wanted to share with you guys is that for the general questions that were asked every day, we studied the ratio of the absolutely accurate evasion and factual error through time. So, and it was very consistent. This means that there was no impactful effort from Microsoft to solve the problem of inaccuracies in the chatbot answer regarding election-related questions, unfortunately. Here is the result of the study on the influence of the language of the query. So there is an impact of the query language, as you can see here with this graph. We can observe that here English provides the most accurate results with 30%. We can also observe that French produces a lot of evasions in comparison with the other two languages. And unfortunately, German was the language with the most factual errors. Okay, a final graph here to share with you guys. Labels distribution. So here we can see how are distributed factual errors, evasion, and political imbalance. If we deep dive into factual errors, we divided them into two subcategories: misleading factual errors, when the chatbot provides an answer that seems true but is not, and nonsense factual error, when the answer is completely made up and completely nonsensical. So we observe here that we have namely we have a higher percentage of misleading factual error rather than nonsensical factual errors. For evasion, we split it also into three subcategories, and we see that the deflection is the one with the highest percentage. Here, deflection means that that the chatbot is answering is trying to answer a question, but it's not the question that you asked. It's a question that is somehow related but different. Okay, we can also note that we have 7% of political imbalance. We wish that this number will be lower in the future, but I personally wish that this percentage would not get higher for future elections. Just in case, the slides will be shared on the webpage of the conference, but I have put here details on all the categories and subcategories for the labels in case you're curious. Same here, I have put two factual error examples just in case you're curious, but you can see them afterwards. Am I being late? Because I can skip this one and
yeah, 1 more minute max.
Okay, I can move on to conclusions. And here, so you have this QR code in case you want to see more prompt examples and more chatbot answers examples with more errors also. So don't hesitate to scan the full report if you want all the details. And to conclude, okay, we had in this study 30% of factual errors, which is a big number, and also something I didn't have the time to deep dive into is that the links that the chatbot provides in the answers can be very accurate. It's just that the answer manages to twist the correct information in the source while generating text. So this is not a great thing, and a behavior that needs to be further studied in the future. And also we can note that the answers might be different from one time to another when you ask the same question, but they are consistently inaccurate on average. So yeah, big tech companies providing this kind of chatbot really need to work on that. And yeah, if I talk about future work, we really want to deepen and extend this work to other chatbots like ChatGPT and Gemini maybe. And we will keep working on election integrity with the upcoming European elections, for instance. And this is a project that we already started thanks to NGI Search fund. And we will be happy to let you know about the results of this European election project in the future. And that's it from me. Thank you all.
Thank you, Sonia. Any questions? Yeah.
Yeah, very interesting work and very ambitious one, I would say.
And risky.
My concern about those categories that you wrote there. For instance, I feel, maybe I'm wrong, that some questions need some answers which are strongly depending on the context. For instance, how I can political imbalance. For instance, just a trivial example. If I ask what said Donald Trump about this and this and this, the system can provide me what Donald Trump said. And the fitness of the answer which was can be checked against what really Donald Trump said. But if the question is on the same topic, but is something a little bit related to interpretation of what Donald Trump said, here one can imagine quite a lot of more or less imbalance. So in my view, it's rather difficult to define this imbalance. Another example, if I want to say what is the political doctrine of this party, naturally the system provides what this party intends to do when it will be maybe elected. So this is strongly imbalanced because the answer is related to that party, not to the other parties.
So the question will be what metrics are used to classify that it's imbalanced or not.
And the same for the accuracy.
Yeah, also, in a similar matter, like apart from that, which I don't know if you have an answer for it, do you plan to compute an agreement in between the annotators, like a judge agreement, some kind of metrics that are evaluating how these labels are assigned?
Yeah, so just to answer the first question before this one, what I completely hear what you say, and this is a great comment. And what I wanted to insist on is the fact that we try to automate a lot of things, but for the data analysis and the data labeling, we keep humans in the loop. As you can see, for analyzing qualitatively the data and labeling, we had 13 persons with high level of expertise that were researchers. And when they annotated the data, they had the questions you were asking in mind while labeling. But I agree with you. The questions and the way you label the answers, this is really highly dependent on the context, and that's why we really need humans to supervise that part, for now at least. So I hope I'm answering correctly your questions, but I will think about it a little bit deeper next. And for your question, Aurora, about the metrics, yeah. In most of our studies, we do compute these agreement metrics. You're perfectly right. This is a very important point in the methodology. Here, in that case, it's really out of time. We didn't compute the metrics, but we had somehow a control group to check some chatbot answers and really collect their feedback, and do some comparison. But it was really on the fly. It was not, no metric was computed for this time. But normally, if we didn't have A/B testing issues and need to patch some problems with the pipeline, we would have done it.
Okay.
Thank you very much.
Thank you.
Thank you.
And now I would like to welcome Andy.
So this is well, I should introduce myself first. My name is Andy Donald, and I'm a research fellow in the Data Science Institute and Insight Centre for Data Analytics, based in University of Galway. So I'm unit lead for the Applied Innovations team. So this is basically a unit that is dedicated to kind of applied research. So LLM innovations is a particularly good example of such an area. And then Juan Chan is a research associate with the Applied Innovations team. So Juan did a lot of work in preparing the proposals and continues that hard work on the project now itself. So what we're and I should go on to the next slide. And we also get a lot of input from Professor Paul Beutler, who's a professor in data analytics in the Insight Centre for Data Analytics as well. So what we're, just to go back to the name of it, so what we're proposing for this this presentation is a comprehensive open source system called OK LLM. And what it attempts to do is to look at many of the issues that have already been described today, and generally as well, like bias, like computational complexity, hallucinations, etc. But it does it. The intention here is to look at it from a knowledge extraction perspective. So slightly unique, perhaps, and to.
Sorry for the interruption, but we're not seeing the slides. Is that only me?
Sorry, I beg your pardon.
Yeah, that's a problem because there are two screens, so I'm not sure.
So we see a list of PDFs.
But I think I got you now. Do you see that?
Okay, there it is.
Thank you.
Okay.
Thank you so much.
Sorry about that. You didn't miss much. It's okay. So yeah, so the introduction's there. So this is the team currently working on the project. I should note just before going into depth that this project has just begun early this year, so we're in the early phases of it. So we're going to be talking about what we're hoping to do in the next 10 months, in particular, and hopefully beyond. Very quickly, just Insight. What Insight is it's a nationwide research centre based in Ireland, so it covers many of the main universities within Ireland itself. We're based on the west coast there, so right in the Atlantic, so probably as far away as possible you can get from Greece. So there's a huge amount of research going on. So in particular in Galway itself, there's a lot of work within the LLM kind of sphere. So we're embedded right in the middle of all of that research. So our proposal is to introduce a system that we call OK LLM. So we talked about a lot of the issues that LLMs currently have in deployment. So computational needs, obviously, bias detection and remediation if possible, hallucination, and the explainability of results. So explaining the metrics that, so briefly touched on it at the end of the last presentation, so talking about the metrics and how to explain why this result was reached, etc. Is particularly important as well, because you want to make more transparency onto these LLMs, and there's no point in making a system that can't explain its own results, essentially, from my perspective anyway. So there's a duplicate slide there, apologies. Sorry, no, this is the second one. So what we're proposing, and this is the work that is currently ongoing, is that we have 3 distinct components for the architecture. So this is, and each of them will look to address specific gaps that have been mentioned previously. And just at a very high level, these components are knowledge distillation. So this is looking at bias detection and computational issues through knowledge transfer. And then one of the unique aspects of this that we hope is that the knowledge graph automation of the generation of the knowledge graph and the verification of that knowledge graph in order to verify that the knowledge graph, that the traversal through the knowledge graph is correct and is a valid result, and then to present that through explainability. So this is looking at how you might again show transparency to the actual results of the system itself. So just very quickly, so that the general pipeline. So here we talked previously about the knowledge graph, or KG driven knowledge distillation. This is obviously a cyclical process. So we generate a knowledge graph, we pass it back, and we improve it and so on. And then the third component, then we'll look at the KG visualization, and then explainability and verification associated with that. So the architecture itself. So again, this is very high level. So we have the concept of a teacher and student model. So basically looking at doing the knowledge distillation here through this, and then passing it along to the second component, and then passing back the knowledge graph that we've generated and verified, and then ultimately then visualizing it beyond that. So I'm just going to talk about some of the ways in which we're planning on doing this in particular, because I guess this is probably a relatively well-trodden path. But before that, I just want to introduce some of the data sets that we've identified. So there's probably a few more that we can introduce on top of that, but these are the ones that we initially have found what we hope will be extremely useful to us. So the search engine result pages data set, we've one identified in particular. So it's basically just information about from search engine results, and so on, the amount of searches for particular keywords and everything search engine optimization based associated with that particular search. And then a data set people are probably familiar with here, the MS Marco passage ranking data set as well. So this is what we're hoping to initially start with. And just I mentioned there about the knowledge graph, the automated knowledge graph and knowledge extraction process that we think is quite unique in this whole process. So previously we have both experience working with a knowledge extraction framework called Saffron, which is developed over a number of years within the Insight Center. So it does quite a lot of it's very flexible engine. There's currently version 4 is available, open source through GitHub, and version 5, which is a Python library, has just been completed, and we're hoping to use that as a kind of at the core of our project. But basically what it does is it allows knowledge extraction from text using NLP techniques, term extraction and term similarity scoring, taxonomy extraction and knowledge graph generation. So that knowledge graph generation is obviously the key part of this that we will be utilizing. So generating knowledge graph based on text, essentially on large corpuses of text. In terms of the bias detection that we've previously worked on, so that there's a couple of papers that we've been involved in the past year or two with a company that deals with chatbots for customer support. So essentially looking at places in which biases get introduced into data sets, models, and how bias is handled after model deployment as well. So when model is actually answering to verify that if bias is in place on a deployed model. The particular focus, I guess, on that research is very much human in the loop. So you have a data set that you want to essentially determine if there's bias present in it, and the detection is done sort of in a pre-processing phase. So it's presented to a user who is looking to create a new or to use that as training data for a model or for an LLM, etc. So that the evaluation is given based on an accuracy score about the level of biases within this data set, the types of biases as well, which is the particularly difficult aspect of all of bias detection, which is the many different types of bias, and how to accurately extract out those particular types of biases from text and from data sets. And further on that as well, we've also embedded kind of knowledge graph generation on using a kind of a semantic approach to in order to give information about the healthiness of a model or a data set or a data space as well. So this idea of generating model data cards or model cards or data space cards, we've looked to kind of to wrap all of that up within a kind of a knowledge graph that will detail biases across a data space, across an ecosystem of models that are in deployment or have previously been trained, etc. And then finally, one of the use cases that we hope to embed this in is that we have a some colleagues who work on the Peers project, which is New Horizon project, that is looking at generating a knowledge dashboard of data around readiness for what's the CBRN, which is readiness towards dealing with various different types of emergencies across Europe. So in terms of how ready member states might be in the case of a chemical attack or chemical or nuclear, etc. So what we're hoping to do here is to utilize that as part as one of the use cases for OK LLM in terms of a data source. And then, so just very briefly on what we're looking to do this year and early next year. So, like I said, we've only kind of begun the project in the last 2 months, so we're very much exploring. We've been focusing on what we know, so that knowledge graph automated generation process, how we might need to enhance Saffron to match our needs, etc. But our intention is by September 2024 is to have initial draft version of the 3 components, and by February 2025, which I guess 12 months after starting, first complete delivery with a domain focus. We were hoping to focus on politics as well, as previous team was. But we have to figure out exactly how or what we're going to focus on for that specific domain itself, because obviously it can't just be politics in general. It has to have a focus. And we have a few ideas, but yeah, we're still thinking about that essentially. So that's myself.
I understood that this is a starting project, right?
Yeah.
Okay. If I am a user, suppose I am a user, and I would like a better explainability of some answer, how your system, by visualization of the knowledge graph, can improve the explainability for me? I don't know about inside of this machine.
Yeah.
I have some answers, and how your system.
Yeah, it's exactly it's one of the main kind of focuses of the project, and I guess that technically what we would how we explain the result that we got will be through analyzing how the knowledge graph is traversed. So basically, understanding how we went through the knowledge graph in order to land this particular result. Visualizing that is something that and providing so it's not enough to make that understandable.
Sorry for interrupting.
Yeah.
I see the graph, right?
Yeah.
With the nodes, with the links.
Yeah.
And there is a mesh like
structure.
What? I look at that graph and I'm doing what?
Well, so it's
get some explainability.
Yeah. So this is exactly kind of what we're thinking about here is that we can explain how we got to that result by looking at the graph, but we need to convert that into a visualization with a specific metric that says we're suggesting that you know, the XYZ is an issue with this particular result. We can tell that because we've first back and we saw the points at which issues might occur or biases was detected. So another what I was thinking of proposing for this was to utilize the concept that semantic kind of structure to which we've done in previous projects, which is generate these data and model cards and generate a standard for that. What I was going to propose for that visualization was to extend that basically to say this search result, this is the ingredients to this search result, and have a card visualizing those to say that it's 30% bias, you know, the potential that this is it contains hallucination, for example, etc. So this is basically create a semantic kind of view of that card, that will take in all of the kind of the technical explanations that we've extracted out.
So given a graph, I could right click on a node and it would pop up with this card.
Yeah, well, so yeah, that's one way of showing it, yes, but it's probably not the most useful for somebody who doesn't know about graphs. So we have to figure out how to bring that beyond it, basically. And so that semantic approach was, I hope, will be one way of doing that, essentially.
So, so so does that mean that when you are visualizing a knowledge graph, it means your entities within that graph, which is representing a node,
yeah,
and then relationship between those entities will be visualized.
Yeah.
And then from user point of view, what data is being stored or what information there is in the system, it's complex. And then you are saying when you are visualizing that in a semantic way, it means it is representing nodes and their relationship, entities and their relationship. And then out of that visualization, are you going to identify what relationships or interactions with the entities are valid, or are you marking or identifying?
Yeah, yeah, more or less.
If I go deeper, how will you think you build your graph? I mean, is it by data-driven knowledge,
yeah,
model-driven, or
well, so
about data-driven can be difficult to evaluate.
Yeah, so Saffron is the tool that you know we've used for this automatic knowledge graph generation previously. So this is about so it's flexible in that it does the entity extraction or the you know term extraction in this case, or whatever, and similarity and kind of the other metadata associated with that. So it extracts that and extracts a taxonomy associated with that data, essentially, and then from that, those relationships. So it's flexible enough to allow the identification of relationships, but also to expand to.
But you fix the nodes or nodes.
So that's there's an option to regenerate based on manual manual fixing of the nodes, which is obviously that's the human in the loop. But as far as I understand, some of the new features might be looking to attempt to solve that in the coming year. So that's the tough part.
Question. Oh, everybody should send the slides to the chair.
I haven't. I have all of them.
All of them. Yes, good. Excellent. This I give my mind.
I think you deserve a round of applause.
Thank you. Okay.
You have 2 minutes for the copy.
2 minutes. Okay, thank you all for your for your good questions and your attention. And people in the chat, a ver. Okay, let me. Thank you so much.
The idea is the following. The guys there in the United States, they set the meeting
Uh-huh.
and then.
Ah,
this is the thing.
give me 2 minutes that I say goodbye to the people in the.
Yeah, I'm sorry.
No, don't worry. Okay, guys.
We are still here.
Thank you so much.
Thank you.
People from everywhere.
Thank you for calling us.
Bye.
All right.
Bye bye.
Thank you.
Thank you. We miss you. Next time you should be on site.
Bye.
We will try.
Yes.
Trying is not
Also.
enough. Succeeding is important.
Technical manager.
Thank you.